Joining us. Go ahead and get started here. My name is Baron Schwartz. This is a photo of me and another photo of me. You're more likely to see me looking like the photo on the right-hand side. That's me speaking at last year's MySQL conference. I don't generally dress up a lot. If you do see me at a conference, please say hi and introduce yourself to me. Give me your business card. I always enjoy meeting people and meet a surprising number of people in person that I've met over email or through some channel such as this webinar, and that's always a pleasure. I am an author of High Performance MySQL 3rd edition. That has just been released, and in fact just yesterday I got my author copies. O'Reilly sends their authors 10 free copies of the book, and those just arrived yesterday, so I've been holding in my hands and admiring how pretty the 3rd edition is. And so that should be, I believe it's shipping now. The print edition is shipping now to people as well. The ebook has been available for a little while. And I've also contributed to some other books, including Web Operations. I contributed a chapter on database operations to that book. I've written a variety of open source software. On the left-hand side is sampling of some of the things that I've created over the years outside of Percona. And on the right-hand side, so a few of the things that I've created in Percona. Percona Toolkit is actually the combination or the successor to Motkit and Aspersa toolkits that are listed on the left. And this is generally a series of tools for administering MySQL more successfully, more safely, more productively. The monitoring plugins is what we're going to be talking about today, and something new that we've been doing relatively recently is we've created tools.percona.com, where we have a variety of tools for MySQL users, and we're going to be planning to add more tools to that in the future. Right now there's a configuration tool that can help you generate a configuration file for your MySQL server, and there's a query advisor tool that can analyze your SQL and help point out bad patterns in it. And of course I work for Percona, and we provide services on the left, consulting, support, training, conferences. Talk a little bit more about our big upcoming conference, and engineering services, all for MySQL. Our goal is to help make people more successful with MySQL, help them succeed in their deployments. And on the right-hand side is a series of open source software that we create. All of this is free and open source. Percona Server is an enhanced version of MySQL Server. It's 100% compatible, drop-in replacement for MySQL. Percona Extra Backup is the only open source hot backup tool for InnoDB data, and compares pretty closely to MySQL Enterprise Backup in some ways. Percona ExtraDB Cluster is a new clustering and high availability technology that we've created for the MySQL server. It replaces traditional MySQL replication with a new type of synchronous replication. And I actually already mentioned Percona Toolkit, and there's a variety of other software that's available from Percona. It's all on percona.com/software, and you can just download it and use it for free. And all of that is fully supported by our MySQL support contracts as well. So what we're going to talk about today is monitoring, specifically the monitoring plugins that I've created, but also in general how to monitor MySQL more successfully, because there are certainly better and worse ways to monitor MySQL, as with any software. And I'll cover a couple of different types of monitoring that I think are useful to help distinguish different purposes, and that can clear up a lot of confusion. And this might sound like it's just semantic, but it's actually pretty important. I'll talk about what to monitor, which is perhaps even more important, and then a variety of monitoring tools. I'll mention them briefly, and then I'll go on to our monitoring plugins that I've created. We've created plugins for Nagios and Cacti, and I'll give you an overview of the Nagios plugins and a series of screenshots, which I think are the best way to understand the Cacti templates. So there are, in my mind, two types of monitoring. And this may not be the only way to look at this, but it's a way that I have found useful. And that is, the first is capturing metrics and statistics for historical analysis, graphing, trending, those types of things. And the second is detecting faults in the system and alerting on them. So for capturing metrics, I like to do something very different than I do for detecting faults in the system and alerting on them. For capturing metrics, I like to capture everything, measure and record everything, because the typical thing that happens if you haven't recorded everything about your system, you're going to have some problem. Let's say it was a database server crashed last night or something ran very slowly, and the question is always, well, what was happening in the system at that time? And it seems to be sort of a Murphy's Law kind of a thing, that the one thing that you don't capture and record for later analysis seems to be the one that you want. And it's, of course, impossible to really monitor everything, impossible practically, and it's just impossible, period. But it's nice to try. It's nice to capture at least everything that you think is important. And that's the approach that I like to take. For fault detection, the way that I like to approach this is monitoring system health. Rather than capturing metrics about things and recording them for later analysis, I want to figure out when something is unhealthy or is not behaving as it should, and then alert someone so that the problem can be resolved. And there really is a whole different set of needs and constraints for a system like this than for recording metrics. So the typical problem that comes up with fault detection systems is that you get too many alerts, and the alerts are not helpful. You'll get alerts that you can't do anything about. You'll get alerts about systems that you don't manage, or you'll get alerts about something that's not really wrong. You know, maybe a system has high CPU usage, but that might actually indicate that the system is working well rather than it's working badly. You'll get false positives, such as a cache hit ratio exceeding a threshold, and there's really nothing wrong with the system at all. And what usually happens is that people get so many spammy alerts that they set up filters on their email, and they either filter them away into some folder that they never look at, or they just delete them entirely. And it's often also, especially with non-actionable alerts, alerts that it's not clear what to do about, it's often unclear who owns them and who owns the systems in question. And so people will filter out everything because they believe that someone else is responsible for that. And as a result, when things really do go wrong, a lot of times nobody even gets the alerts or notices that the alerts aren't being sent when the monitoring system itself fails. I've seen many cases where someone changes the firewall rules and the alert system is not able to send emails anymore. And nobody actually notices because they were all filtering those alerts out anyway. And so something that has happened to us many times is that a system will crash because of a full disk or something like that. And the leader or the supervisor of the system will ask kind of the obvious question, why didn't we get an alert about this? And when we go and check Nagios, we find out that indeed Nagios did attempt to alert, but nobody was noticing that the firewall rules had changed and the emails couldn't get through. So this happens pretty frequently, and it's really a human problem. It's not a system problem. And I'll show you some ways to address that later. But this is by far the most common problem that I hear from people when I talk to them about alerting systems. And I had a meetup last week with a group of people here in my town, and we talked about the monitoring systems there as well. And as I always do, I just asked everyone, well, how many of you have email filters set up on your alerts? And basically everybody who had alerts had email filters. And I've even met people who get tens of thousands of useless alert emails every week. Now that's kind of an extreme example, but it does happen. And in that case, the case where there are tens of thousands of alerts a week, we're talking about a very large corporation with many years of systems sort of accreting over time. And the person that I spoke to who was getting all of those emails had no ability to actually shut off the systems or configure or change the alerts that were sending him all of that noise. And yet he's supposed to be responsible for keeping the systems up and running that he is, that he does own. it's a pretty difficult thing to balance. So I think probably most of the attendees of this webinar, if you have an alerting and monitoring system, you probably know what I'm talking about, so I won't belabor the point anymore. So I like to monitor only as much as needed. That's sort of the short version of my strategy, my philosophy on alerting things. I don't want to monitor on things that are not actionable. I don't want to monitor on things that are not true indicators of a system really being unhealthy. I don't want to monitor on something that just looks abnormal, especially when you get to a large number of servers. Something is always abnormal, and abnormal doesn't necessarily mean anything other than that someone is doing something different, and different is not necessarily a cause for alerting someone. The question that often comes up is, why don't we have a single tool that can do both monitoring and alerting for fault detection and for statistics and metrics of systems? And there are a few good reasons why such tools don't tend to work very well. Now there are tools that do this, and some of them work reasonably well, but in many cases there are sort of conflicting requirements for those tools. The tool that's capturing data for historical trending typically doesn't need to capture very frequently, and it usually needs to capture everything all at once and then cache it so that for repeated accesses to that data that you don't actually have to, for example, go across the network and capture statistics from the server that you're monitoring again and again. But that's actually, you don't want to do that for fault detection. You don't want to be monitoring the contents of a cache file. You want to monitor the real system. So there's a conflict in the requirements there. For metrics collection, you'd like to capture all of your statistics at a single instant in time so that you have a consistent view of the universe. It's rarely possible to actually do that, but it's helpful to get as close as you can so that you're not looking at counters from one time range and comparing them to some other counter from some other time range. It's nice to be able to compare apples to apples when you're correlating graphs, for example. But for a fault detection system, you again do not care about consistency. What you really care about is what's happening right now. You don't want any sort of time delay or artificial offset in your graphs. And this all sort of feeds into point number 3 on this slide, which is staleness. For fault detection, you absolutely don't want anything to be stale. For capturing historical metrics, staleness is fine. You know, if something is 30 seconds or 45 seconds out of date, in most cases you're not interested in looking at real-time data anyway. You're maybe comparing this week to the same week last year or something like that. So staleness is not a big deal in a graphing and metrics collection system. So for those reasons, it's difficult to understand and to create a system that can do both types of monitoring well together. There are a lot of monitoring tools, and I'm showing this screenshot. This is a website at Stanford that tries to keep tabs on which monitoring tools are available, and you can see on the right-hand side here, if the font is not too small, you can see the right-hand column is the edition history, which means the new tools that were introduced every year. And you can see last year there were, what is that, maybe about 30 or 40 new monitoring tools were introduced last year alone. 2008 looked like a banner year. There were a lot of monitoring tools introduced that year. And since the beginning of 2012, we've already got, looks like over 10 new monitoring tools this year alone. So the problem is not that there are no good monitoring tools. In fact, one of the problems is that there are so many. And it can be a difficult decision trying to find a good monitoring tool and separate from all of the ones that you don't want to use for whatever reason. I have a theory about why there are so many monitoring tools. And to illustrate it, I just drew a little graph with an estimated 5 man-days of work to evaluate a single tool. I think that's fairly realistic to set up and look at the capabilities of a single tool. And I estimated that most people who I've spoken to, and judging by my actual experience with people who do write some sort of monitoring tools or scripts or cron jobs, they typically think that it wouldn't be all that hard to write a monitoring tool that does what they need. And yet on the far right-hand side, we have let's just say that there are 500 tools. That's like 2,500 man days of work to evaluate all of those. And so suddenly it looks very attractive to write your own tool instead of evaluating all of the tools that are available and finding ones that might work well for you. So I believe that there's sort of a phenomenon of kind of a critical mass. When you get a certain number or variety of products, it becomes either prohibitively expensive to research and evaluate all of them and decide which one is the best, or it appears to be prohibitively expensive to do so. And so creating your own and adding yet another one to the zoo starts to look very attractive. And I think this is how a lot of open source monitoring tools are born. I don't think that this is completely unique to monitoring tools. I think this also happens, for example, with the new generation of non-relational databases seems to suffer somewhat from this phenomenon as well. There are NoSQL database websites, and you can scroll through them and find hundreds and hundreds of new databases that are popping up all the time. So I think this phenomenon tends to happen in a lot of different areas. In the world of MySQL users, there are, even in such a sort of a constrained sector of the market, there are already a lot of tools that I find that are pretty popular. And on the left-hand side, I begin with Nagios and Cacti. Those are a couple of the ones that we have found to be most popular for our users here at Percona. It's an admittedly biased sample. Nagios does fault detection. Cacti does metrics and graphing. Underneath of that, we have Zabbix, which is a tool that's similar to a sort of a combination of Nagios and Cacti together. Does both of the functions in one tool, and we have some customers who are using that. MySQL Enterprise subscriptions come with the MySQL Enterprise Monitor, which is a specific tool for monitoring MySQL. I should make a note here that Nagios, Cacti, and Zabbix are generic tools. They can monitor pretty much any component in your enterprise, whereas MySQL Enterprise is a very MySQL-centric tool. It does have the ability to be extended and to add custom monitors and plugins into it, but by default, it's designed to be a good MySQL monitoring tool. And it is good. Some people don't wish to spend that much money on their monitoring tool, but for those that do, we find that they're very happy with MySQL Enterprise Monitor. New Relic is a web-based software as a service monitoring and application performance management tool. Our customers who use New Relic are typically able to resolve a lot of their problems without requiring us to intervene. New Relic is more than just a monitor. It's an application performance analysis tool, which means that it actually instruments your application from the JavaScript. It's built for web applications, and it instruments it from the JavaScript that runs in the browser to the code in the application itself, all the way into the database calls and calls into the caching layer and even the operating system in more recent versions of the tool. It's quite sophisticated and not all that expensive and extremely helpful. So especially for Rails users, it's dead simple. You just drop in a gem and you're up and running in a few minutes. It also instruments Java, .NET, Python, PHP, and perhaps some systems that I'm not remembering at the moment, but it does work on a variety of platforms. Circonus is a metrics, primarily a metrics gathering tool from OmniTI, and it's a very nice, very sophisticated tool for gathering and visualizing and analyzing a lot of metrics. On the right-hand side, we have MRTG, which is the multi-router traffic grapher. That is kind of the granddaddy of all of the, there's a whole category of these graphing and metrics collection tools that use a particular back-end database to store their data in. MRTG is the original. The back-end database in question is called RRD, which stands for Round Robin Database, and it's a fixed size file that never fills up. What happens is that as you reach the limit of the capacity in the tool, in the database, it starts to overwrite its tail and it goes around in a circle. And it performs really nice aggregation So you can record metrics with several different levels of aggregation, for example, by minute, by hour, by day, by month. You can do all of these in a single file, and you can use it to generate really beautiful graphs. And a lot of metrics collection tools are wrappers around the RRD files, including Cacti, actually. Moonin is another one, and there are some plugins for Moonin that are derived from some of the plugins that I've written. Monit is Monit is sort of a little bit different in this category. It's a proprietary monitoring system that is relatively lightweight and easy to get set up with, but it does a whole number of other things as well, including it can watch the health of your processes and restart them when they fail, and so forth and so on. And we have a number of customers who are using Monit. Monyag is a desktop monitoring system that's very specifically for MySQL. You run it on your desktop machine, and you tell it how to connect to MySQL, and it gathers metrics and information from the MySQL server and presents it to you in a variety of views. Some of it is graph-based, some of it is sort of a process list updating what's happening on your server right now. And I would say that many people consider it a good alternative to the MySQL Enterprise Monitor. It's not open source, it's not free, it does cost you some money, but it's a lightweight way to get started with a handful of servers especially. I would not say that it scales to a very large enterprise, but if you're only running a handful of servers, it's quite realistic to use it. Xenos is one of those all-in-one monitoring tools that's targeted towards a large enterprise, and it does inventory of all of your systems, captures metrics from them, can send you alerts when they're not healthy, can automatically discover things that are on your network. And there's a variety of other tools that are more or less similar to some of the tools that I've described here. So what I've done here is kind of give you a sample of some of the tools that I see people using in real life, and you can tell already that there's a pretty big diversity here. And I've tried to give you the diversity of functionality to indicate the sorts of kind of different categories that some of these tools fit into. And there are many different examples in each of these kinds of categories, many sort of equivalent products, and you might expect that with hundreds and hundreds of monitoring products available. So this is, these are some of the tools that I would say if you don't have a monitoring system, these are certainly worth evaluating if you want to do sort of a comprehensive survey of what a lot of people are using. The tools listed here, and I've probably forgotten some, are well worth investigating and thinking about. So this might be, if you trust me as a filter, to filter down that very large list for you and present you some tools that that are worth checking into. This might be a starting point for you. The Percona monitoring plugins are much less broadly focused, and our philosophy here is that we don't want to create yet another tool. What we would like to do is enable people to be more successful with the tools that they already have. And in many cases, as I mentioned, that is Nagios for alerting and Cacti for metrics and historical graphing and trending, those kinds of things. And a lot of people find that quite workable. Nagios is one of the biggest and most widely deployed enterprise open source monitoring solutions. So it seems like kind of a no-brainer to target that, and there are other reasons for that as well. I'll go into a little bit later. And Cacti is probably the easiest RRD tool front end to use for a lot of people. It has a nice web interface, and you can set up monitoring of different servers and create graphs all from the web interface. So those seem to suit a lot of people's needs, and that's why I chose to write some plugins and templates for these. And they are, like all of our software, they're free and open source. They're covered under our support contract, so if you have any trouble with them, you can get commercial support. And you can also use our forums for free support, or our mailing list for free support. As time permits, we'll answer the questions that we can there. But in any case, whether you need our help or not, the software itself is certainly free. So I'll go through Nagios and Cacti successively, one at a time, and kind of show you what we've built here, show you what you can do with these plugins. Starting with Nagios. As I mentioned, Nagios is primarily for detecting when systems are unhealthy and letting people know about it. There are some plugins that you can add on to Nagios for recording metrics that are sort of specially formatted conventions in the output of the monitoring data that's collected. But by default, Nagios is really for finding out when things are wrong. Nagios has a completely plugin-based architecture in terms of monitoring health on systems. The system itself, the Nagios system itself, runs on one server in your enterprise and executes these plugins which reach out to the systems that you're trying to monitor and report the health on them. So plugins are actually, it's a very simple set of conventions. You should be able to execute them, whatever that means on a particular platform. That might mean shell scripts or Perl or Python or PHP or C programs or anything. Anything that can be executed. It's just a program. That's all it is. And there are some conventions for the command line arguments that you can pass to those programs, but the conventions are just that. They're only conventions. And you can write your own plugins and make them do arbitrary things and then configure Nagios to communicate with them. And it's a completely flexible system. The plugins indicate the health of the system that they're monitoring by executing and then returning the exit status of the executable itself indicates the health. So 0 is okay, 1 is warning, 2 is critical, and there's a couple of other states that mean more advanced things. But for most cases, that's pretty much all you need to know. 0 is okay, anything else is not okay. And the plugins, these little executables for checking the health of systems, can also print out text to their standard output, and Nagios captures that and can send it in emails. You can view it in the web interface. It can be used for deriving performance metrics, lots of things that you can do with that. And there are a few conventions about how that text can be formatted so that different data knows how to deal with it in kind of a structured way. But there's nothing carved in stone. Again, you can output nothing. You can output highly structured data. It's all up to you. The nice thing about these plugins is that there's a large variety of them, and everybody is pretty much compatible with Nagios' plugin semantics. So if you've got Nagios plugins, you can use them on other systems. You can use them on Zabbix. You can use them on any of the forks of Nagios, such as OpsView and Asinga. They'll work in most of the big enterprise-y monitoring systems like Xenos or some of the systems like that. So a Nagios plugin is more than just a Nagios plugin. It's useful for lots and lots of systems. So by creating a set of Nagios plugins, we've actually created something that can be used on many different platforms, not just Nagios. There are a lot of plugins for Nagios. There's a couple of plugin websites. If you search for Nagios plugins on Google, you'll find them immediately. There's a Nagios plugin exchange, and there's the official Nagios plugins that ship with the Nagios product itself. And there are many, many plugins for MySQL. So it's a reasonable question to ask, with all of those plugins out there, why should Percona create yet another set of monitoring plugins for MySQL for Nagios? And I'll get into some of the reasons, but I think it's without criticizing any of the plugins that are out there, they didn't really meet the needs that we have, and most of them sort of contribute to or play into the kind of spammy alert problem that I talked about earlier, which is that human factor that makes monitoring such a hard problem in most cases. So there are two official MySQL plugins that ship with Nagios, and those are good. There's nothing wrong with those, and I encourage people to use them. And there are the Percona monitoring plugins that I'll be introducing as we go. So as I mentioned, one of the problems that we really want to solve is to sort of create a system that makes it easy and natural for people to avoid creating a lot of noise that generates email filters and so forth. I also wanted the plugins to be high quality. There's nothing that I dislike in software development more than playing whack-a-mole with bugs. You know, you fix a bug and then you introduce another bug and you fix that one and the first one comes back. And that's no fun at all. And the way that I avoid that is by writing a test suite for the software. And none of the existing Nagios plugins were testable, or at least not testable with a reasonable amount of effort. Software has to be designed from the beginning to be testable. It's not something you can really bolt on afterwards. And so that was yet another reason to write new plugins so that they can be higher quality. The plugins that I've created also have pretty good documentation. I don't claim that anything is perfect, but I think that you'll find it more than adequate. And I keep mentioning that it's free, but it never hurts to mention again, it's free. We've also designed plugins that integrate well with other tools, such as Percona Toolkit. There are some tools in Percona Toolkit that can help you monitor replication delay, for example. The show slave status command that's inside of MySQL is not really trustworthy for doing that, so there's a PT heartbeat plugin, and there's a PT heartbeat tool in Percona Toolkit, and there's a plugin that can monitor that tool inside of the Percona Monitoring Plugin. So we've integrated these things together nicely, and I've taken extra care to make them easy to extend and customize. I've written them in a very structured way. I'll show you a screenshot of some of the code here in a moment. It makes it trivial to kind of use an existing plugin as a basis for a new plugin. You don't have to go reading through and understanding a lot of code. You can simply change the small amount of code that actually relates to the topic that you're trying to, the task that you're trying to achieve. And if you are, like myself, a testing fanatic, you can write your own unit tests very simply. And they're written in shell. That means that they're not compatible with Windows, but people don't use Nagios plugin compatible systems to monitor on Windows anyway, by and large. If you're monitoring servers that are running on Windows, you're either monitoring them from a Unix server running Nagios, or you're using something else, something like one of the commercial monitoring systems that's available that runs on Windows. But people don't tend to use Nagios and Nagios compatible systems very much on Windows. So I thought that shell script was a good target language here. It's completely universal on everything except Windows, and it's high performance, and it's very, very good at executing system commands and capturing the output of them. So it's a natural fit for the kinds of things that we do with Nagios plugins. It's also very simple to write shell. Even a novice can do it. It's not something that requires a lot of advanced programming experience to do, and that makes these tools, these plugins, easier to copy paste into your own plugins or to extend or change existing ones. So here's a screenshot of one of the plugins. This one is, if you look towards the top of the screen, you see the purple text, PMP check LVM snapshots. This plugin is actually designed to check the health of your LVM snapshots. LVM is the logical volume manager in Linux. And I'm showing you here something that's sort of the framework, the scaffolding that's used for all of these different plugins. And that is a couple of functions that determine whether or not this plugin is being executed directly or whether it's being included from some other script. And the reason that's interesting and important is that by executing the plugin only when it's not being included from another tool, only when it's being executed directly, means that you can source these plugins, and the function definitions that they create are then functions that you can call and write unit tests again. So this is, to the best of my knowledge, the only unit testing system for Unix shell script in existence. I kind of invented this. It works fairly well, and it's allowed me to make the plugins much higher quality and much easier to maintain. So when you open up the scripts, you'll see something similar to this. You'll see highly structured source code that's easy to understand, easy to look around and figure out what's happening, easy to extend and write your own. So I've divided the Percona Nagios plugins into two sort of categories. One is monitoring what's happening in the operating environment, and that's everything that supports the operation of an application. I mentioned LVM snapshots already. The next one in this bulleted list is deleted files. I often find that MySQL has file handles that are open, but the file has been deleted off of the disk, and that might be the slow query log or even the InnoDB data files. And as long as MySQL is running and keeping those file handles open, the files will not actually be completely, the contents of the files won't be completely removed from disk. And this is interesting and important for two reasons. One is that if you incorrectly rotate your server's log files, MySQL will keep that old log file handle open in memory and continue to append to it, and you will silently fill up your disk and you won't be able to see why. The other reason is that if you accidentally delete your InnoDB data files and then you shut down the server, they're really gone for good. So it's quite possible to delete the files, not realize that they're gone, run the server for a very long time, successfully with no ill effects from those files being gone, and then when you shut the server down and restart it, when you bring it back up, your data's gone. And you would much rather know about that before you shut down the server so that you can recover those files before they get really deleted from the disk. So there's a plugin that looks at the MySQL process and says, does it have any open but deleted file handles? And it will alert you when that happens. And this, in practice, could have averted many data recovery scenarios that we found, as well as many disk full errors that we found. There's another plugin that will check for privileges of the MySQL data directory, make sure that there are no files that have wrong ownership or permissions underneath of MySQL's control. And this matters a lot because somebody, let's say a system administrator, logs into the system and changes to the MySQL data directory for some reason, creates a temporary file that's owned by root, forgets to remove it, logs out, and now somebody tries to drop the database that contains that file, and that file prevents the database from being dropped. And I've seen other errors as well, such as MySQL has read permission but not write permission, so everything appears to work correctly and it's difficult to figure out what's wrong, but you get permission denied errors when you're trying to, let's say, create a new table. The PID file is something that the MySQL management script uses. The start, stop, and init scripts will use to keep track of the health and status of the MySQL server process on the machine. And if those get deleted, as they can for a variety of reasons, such as a periodic cron job that cleans up old files and cleans up this file that's actually really in use, or a mistake with the init script or a bug in the init scripts, if those files that record the process ID of the MySQL server get deleted, then MySQL can't be started and stopped cleanly. And this especially matters a lot if you're shutting down the system. If you issue a halt command on the server, it tries to stop everything that's running, but if it doesn't have that PID file, the start-stop script for MySQL will fail, and then MySQL is not shut down gracefully, so it gets hard crashed so that the system can shut itself completely off. So those are some of the kinds of things that these plugins really address. And I didn't mention this, but we did a lot of research on causes of downtime in servers. I personally evaluated over 300 emergency cases and drilled down into root causes and preventions for them. And that's where a lot of this list that might look a little bit funny, like why did I choose these sorts of things instead of some other things? Well, it's because these were the problems that really came up as serious gotchas. So that's why I wrote plugins for these very specific things. And then the final one is intended to alert you when there's too much memory usage by any single process on the system, which will usually be MySQL server. And if MySQL starts to use too much memory, it can start to cause a lot of swapping, for example. So those, the previous list here, this is all the operating environment. It's not MySQL specific. It's things that are MySQL related, but not inside the MySQL server itself. Inside of MySQL, we have a variety of plugins to detect and alert specific problems that, again, we've discovered these to be severe downtime risks or frequent causes of downtime. The first one is table checksums. That integrates with Percona Toolkit's PT table checksum tool. Can tell you when there are differences in the data between your master and your replication servers. We've also got a set of plugins that checks replication's health and functionality. And there are actually two plugins for that because there are a couple of different things that you want to check that shouldn't really be mushed into a single plugin. Having specific plugins makes it easier and more precise to measure and report on the health. We've got one that will detect when there are severe problems occurring in the processes running inside of MySQL. Another one that looks at symptoms of severe problems inside of the entity storage engine. One that integrates with the PT deadlock logger tool from Percona Toolkit to alert you when you've got a lot of recent deadlocks. Those are the kinds of things that are often invisible otherwise because the application typically doesn't really report on those kinds of errors. If the application is experiencing a lot of deadlocks, it can go unnoticed for quite a while. And then there's a generic flexible plugin that you can use to monitor arbitrary status plugins. And I'll put a caveat there. There can be dragons in that area, and I'll explain that a little bit more. So I suggest monitoring everything that's appropriate from the previous slides, as well as if you'd like to take a look at Percona.com About Us white papers. There are two white papers on causes and preventions of downtime in MySQL servers, and that's based on the research that I mentioned into those real emergency issues that we've handled. You might want to read through those. There's a lot of detail there. I've presented only a summary of it here in this talk. And in addition to the list on the previous two slides, I would suggest monitoring a couple of status counters. One is the server's uptime. If the server restarts, that's often something that can happen invisibly. People will get query errors, but they don't realize that the server has actually crashed and restarted automatically. You will, if you have a plugin that's alerting you when the uptime counter is too small, you'll have better visibility into that. And then finally, if the threads connected begins to approach the limit on the number of connections allowed to the server, it's something that's very good to have an early warning about, because a lot of times people will have connection pools, or they'll need to reconfigure application servers to deal with this, and that might require some advanced scheduling and even some downtime in some environments. So it's nice to find out about this in advance so that you have time to schedule that downtime. Now, in contrast to the typical monitoring system for MySQL that seems to imply that you should be monitoring dozens and dozens of ratios and so forth, I suggest not monitoring those. I don't suggest monitoring cache hit ratios, buffer ratios, temporary tables per second created, all of those kinds of things. And there's a variety of reasons why those things tend to contribute to spammy alerts. A single threshold on those sorts of ratios and counters is very difficult to find. The threshold that might indicate health is ambiguous and changes from hour to hour and from system to system. So setting up a single threshold is generally, it's a game that's over before it starts. And secondly, they're not really reliable indicators of something really being wrong. It's just a reliable indicator of something being different some of the time, and different happens all the time when you have enough servers. So you need to be careful not to alert on unusual things, but only to alert on things that are unhealthy or wrong. And finally, suppose that the temporary tables per second created is over a threshold that you define. What are you going to do about that? In many cases, nothing. There is nothing to do. It's just the way the application's workload goes. So why even have that alert in the first place? So eliminating these kinds of alerts removes a lot of spam and noise from your inbox. I mentioned that there is a generic plugin that you can use to monitor pretty much anything that you want. So you can monitor counters and ratios of counters and the rate of increase of counters over time, for example. And I have one little example here that this is just kind of a concocted example only to show how the syntax of the tool works. in here I'm monitoring a warning when the threads running is over 20 and critical when it's over 40. So the syntax is compact and very intuitive and straightforward. The documentation explains the -X and -W and -C. Those are also Nagios conventions, by the way. So if you're familiar with Nagios, this will be even more intuitive to you. And the documentation has a variety of examples about how you can do more complicated and sophisticated things, which I don't necessarily suggest doing, but if you have a reason to do, then it's certainly possible. So I'll move on to Cacti now, and in contrast to Nagios, where I kind of talked about what's available, Nagios is not very exciting to look at screenshots. So in contrast to that, I'll actually show you some screenshots of Cacti, because that's the easier way to sort of understand what it does. And as previously mentioned, Cacti is really for capturing historical metrics. The nice thing about Cacti is that it's easy to use. The not so nice thing is that it's pretty tedious to generate your own templates. But I've fixed that with a set of templates and a template description language and some scripts that can generate your own templates. So this makes it very easy. Using the web interface to define templates can literally take you days for a decently sized set of templates. There's a lot of clicking and clicking and confirming and clicking. Probably tens of thousands of clicks for a decently sized set of templates. And you're not likely to get a very good quality set of templates out of it as well, because there's a lot of tedious human error in there. And for various reasons, Cacti doesn't export the templates in a great fashion. So that's why I created a template definition and automatic generation system that's completely external to Cacti. And it comes with a huge variety of ready-made templates for systems much beyond MySQL. You can capture, for example, monitor data about your MongoDB instances, about Redis, about Memcached, about Apache, about Nginx. There's a JMX if you're a Java container user. There's a whole bunch of things in there that you can monitor, and they're pre-made templates for this. And it's so easy to create your own templates, and there's good documentation for that, that a number of people outside of Percona have created and contributed those templates. And I've sort of curated them, done some quality control, added a unit test suite again, because I like testing, and bundled it all together. So so it's ready-made and very easy to get started. So I'll show you how to do that. First thing to do would be to go to Percona.com downloads and click into the Percona Monitoring Plugins, and then just download the tarball. Extract the tarball somewhere on your system, and you'll need to get Cacti up and running. This is pretty simple. If you've got a Debian-based system, for example, all you need to do is run apt-get install Cacti. Confirm. A few minutes later, you're done. And then you'll be able to log in as the admin user, or if you've configured some other type of authentication. Cacti supports, for example, integration with LDAP servers. Log into with an administrative user, and you'll see a system that looks like this. This is sort of your home screen in Cacti. And from here, what we're going to do, I'll show you how to import templates and then set up monitoring against a server. So there's a red oval on the left there on the import templates link. So I'm going to click on that, and this is the screen that I'll see next. There's actually, I'm sorry, I put a couple of these screenshots out of order. It looks like there's a button that you can click to browse for a file, and here I've browsed my desktop system where I've extracted the XML files that define the templates, and I'm selecting the template that I want to import into this system. And I'll select OK, and you can see next to the Choose File button that I've selected that XML file. And then on the bottom right, there's a little red oval arrow on the Import button. If I click that button, a few moments later, I will see a screen that looks like this. A whole bunch of successes. These are all of the different kinds of definitions that are contained in that template. Graph definitions, definitions of different kinds of data to capture and how to present it as graphs, all of those kinds of things, where to collect it from. And you should see little green successes down the left-hand side, a row of success markers. So at this point, the templates are installed, and we're ready to add a device. For the purposes of this demo, I decided that I would graph my personal blog, which is actually on shared hosting on a server that I don't control. But I thought it would be interesting to just go ahead and connect to it and see what's going on inside of that MySQL server that's running my shared hosting blog. This is actually something I had never done before. It just occurred to me to do, so I thought it would be fun. So I'll click on the left-hand side on the devices, and we'll see a screen like this. I'm going to click on the top right-hand. There's an Add button there, and that's how we create a new device. Now, a device is really system or server, so that's just the terminology that Cacti uses for something that you want to monitor. So I'm going to pretend that the MySQL server that runs my blog is a device, and I'll click the Add button. We'll see a screen that looks like this. And I'm going to set up an SSH tunnel. I did that separately from the virtual machine that this is running in up to the MySQL server that my blog is running on. And that SSH tunnel is accessible now to Cacti through localhost. So that's why I've entered 127.0.0.1. And in the host template dropdown, I'm going to choose the Percona MySQL server host template. That configures this host by default with a set of graphs that are appropriate for a MySQL server. I've disabled everything else because I really don't care about anything else on this screen. There are a few other things that you can learn about, but I won't go into that here. And then on the bottom right-hand side, I'll click the Create button. The next thing I'm going to need to do is go to my Cacti server and install some scripts. So I've installed the templates through the web interface, but I also need to put a couple of scripts in that Cacti uses to connect to the MySQL server and collect the data from it. So I'm going to get the Percona Monitoring Plugins tarball onto that server, and here I'm showing it in the terminal, highlighted around it in red. And then I'll untar it. And then I'm going to copy the Percona Monitoring Plugins Cacti scripts ss_get_. There's a couple of scripts there. One of them is a MySQL script, and one of them is a generic script for some other tools. And I'm going to copy those files to user share Cacti site scripts. And the next thing after that I'm going to do is edit the configuration file that's associated with my get MySQL stats PHP script. And you typically only have to define the MySQL user and the MySQL password. In the case that I'm showing here, since this is my blog on shared hosting and I don't have a privileged user on there, I'm also setting some of the more advanced options to false so that I don't try and gather some of that extra data, such as InnoDB status data and replication status data. I don't have privileges to collect that, so I'm just going to disable it here, although I would leave that enabled in the general case. And we're done. So I'm going to go back to my Cacti web interface now, and here we see the results of saving that, what happened after I saved the device, created the new device. On the top left you can see it says save successful, and then there's a link, create graphs for this host. By default, this device or host doesn't have any graphs yet, so I'm going to click on that link. And here are all of the graphs that are available. These are graphs that are sort of attached to but not created yet. The definitions are associated with this host. And I can select any of these that I want to create graphs for. These come from that template. They're automatically associated because the host is defined as belonging to this Percona MySQL server host template. So you can check any of the checkboxes that you want. I'm going to select a few of them here. If you wanted to, you could also click on the top right-hand checkbox and it would select everything. This is typically what I do, but in this case, as I mentioned, I don't have full access to all of the data that I want to grab, so I'm only going to select a few of them. And then I would click the Create button at the bottom. And if you do that, you'll see Cacti will say that it's created all of these graphs, and then if you now that the graphs are going to start collecting data, and you'll be able to view them in a few minutes. There's one more step before I actually go and look at the graphs that I've created, and that is to add the server to a tree. I'll show you in a minute what that means. And I'm just going to place it on the default tree, confirm, and continue. And then on the left-hand side here, you see the tree and you see that host XR blog. I've clicked on the Graphs tab on the top there, the red tab on the top left. And it comes up with this default tree, and that's where we see the graphs that are associated with it. Now the graphs are broken because I just created them, and Cacti hasn't actually collected any data for them yet. But the next time it collects data, which it does by default every 5 minutes, it's going to fill in those graphs, and we'll get to start seeing them collected. If you look on the top right-hand side of this screenshot, there's a tab there that I've highlighted in red. If I click on that, I get to see the whole list of graphs that are defined, and I can select some of those and create a custom dashboard. So I'll select 4 graphs here and we'll create a custom dashboard. And this is what happens after a few minutes when Cacti has started to collect some data. And then after a little while later, we get even more data and then more data. And now you can start to, you can drill into these and browse around and kind of see what's happening in the system. After a little while, I think I came back the next day and I had this. I've highlighted a few things here with the blue ovals. One, it looks like there's some kind of a funny spike in the command counters that corresponds to a spike in the network traffic. It might be interesting to look into. And there's also something on the right-hand side of that first graph, the command counters graph. It looks like there's a period of sustained activity there. And I'm curious what that is, so I'll click on the little magnifying glass to the top right of that graph, and we can drill into that graph. And here we can see a larger view of the same graph. And if I wanted to look at that particular region where looks like there's a blip in the graph, I can click and drag my mouse on it. You don't see my mouse in the screenshot, but the little red rectangle is what happens. That gets drawn on the graph when you click on it. And then when you release the mouse, it'll zoom into that. You can also look at some of the other graphs that have been created. For example, here's one with the select types on the top, and we see that same funny lump. Now what I suspect this is really happening here is that it's just Google is indexing the contents of my blog. But I don't really have any way to prove that. I'm just showing you what's going on inside of the server here. And this was all news to me. Again, I had never looked at any graphs for this blog. Here's a couple of other graphs showing that looks like there's a lot of temporary objects, temporary tables that were created during this, whatever it was, maybe Google indexing. So, so now we've got, graphs created, and you've got historical data so that when something happens, you can look back and see what changed in the system during that time. And I'm going to wrap up by saying that I like to, again, record all the metrics that I can, because you never know what you're going to need when you're looking back at a system. If you haven't collected it, it's too late after the fact, of course. And I like to alert very selectively, again, based on the information that's in those white papers on emergencies that we actually handled. And I especially don't like to reinvent the wheel, so I'm trying not to create duplication, and I'm trying to enable people to monitor MySQL with the same systems that they use to monitor the rest of their infrastructure. And in a lot of cases, Cacti and Nagios seem to work pretty well for that. I'll share these slides. These will be posted online afterwards, and the recording of the webinar will be online as well. Here's some blog posts about the plugins and white papers that I've mentioned, and a couple of other resources that might be helpful to you. There's the configuration file wizard and the query analyzer that are at tools.percona.com. Training, we do public and private courses. We run the public courses around the world in major cities all year long. And we've got a few upcoming dates in Dallas, London, Raleigh, and Chicago. And you can always, there's an RSS feed on percona.com/training, so you can keep updated. And you can also subscribe to our training newsletter to find out when new dates are announced. And the big news, of course, is that we're running the MySQL conference this year in Santa Clara, California. And I hope to see some of you there. So I believe we're out of time now. Terry, if you want to keep going, I'm here as long as you want, and I can answer any questions that people had.
Okay, Baron, thank you for today's presentation. Folks, if you have a question, please submit it through the GoToWebinar questions window in your control panel. We have a couple of questions now. Baron, first, will the plugins be able to monitor XtraDB cluster?
Yes, all of the XtraDB cluster monitoring and statistics are exposed through show status counters, and so you can use that generic status counter plugin to do that. And we don't have any publications on, sort of guidelines on what to monitor there yet, but we should probably have that at some point in the future.
Okay, very good. Could you go over some of the best general combinations of Nagios plugins and Percona toolkit tools that need to run as daemons as their performance overhead implications? For example, deadlocks or other tools like PT stock and or PT sift.
So most of the Percona toolkit tools don't have large performance impact on the systems. One that you might want to be cautious about is PT table checksum, and it's actually designed not to have any impact on systems, but you should test that before you deploy it. PT heartbeat, PT deadlock logger, these kinds of tools have essentially nil impact on the systems. They're just capturing a little bit of status data from the system at periods. I think those are the ones that I've written integration for. I don't think that there's anything else that I've written any Nagios plugin integration for.
Okay. Will the data collection using these plugins have any overhead?
No, it's essentially zero. The Nagios plugins are few. There's only a couple of them, and they'll typically run once per minute or once per 5 minutes in the default configurations. So you're essentially capturing, show status once every couple of minutes in 6 or 8 different plugins. It's a trivial load. You can run show status thousands of times a second. The Cacti plugins do the same thing, but the Cacti plugins actually have some pretty advanced caching to make sure that they only capture one set of show status counters and one set of show variables counters and so forth for every time that the Cacti poller runs, which is 5 minutes by default. So there's even less load from the Cacti plugins.
Let's see, final question. Can you discuss an example and or best practice for giving permissions for particular Nagios plugins that require an enhanced access?
Yeah, that's a great question. There's a documentation section on permissions in each of the Nagios plugins. And I've listed everything that the plugins do, all of the potentially privileged access that they need. Typically what people will do with Nagios plugins is actually run them in a Nagios remote plugin execution environment, which is a highly secure way to run Nagios plugins. And they'll typically grant a sudo for the Nagios user for everything under the plugins directory. And you could do finer grained permissions if you wanted to, but that's kind of the standard way that a lot of people seem to set it up. And that will actually allow the Nagios plugins to do everything that they need to do. There are a few things that they do that would need some privileges, and again, I've listed everything that they need in the documentation. They also need some privileges inside of MySQL, and I've listed all of the things, all of the queries that they run. For example, show status or show InnoDB status. Show status doesn't require any privileges at all, but show InnoDB status requires the process privilege, and so does show process list. So all of that is detailed in the documentation.
Okay, very good. Well, thanks everyone for attending today's webinar. We are out of time now. And Baron, thanks for the presentation. And we hope everyone will join us at a future webinar conference in the near future. Thank you.